Now is it visible?
Yes, sir.
Yes, sir.
Fine, fine.
It was disconnected actually. I'll draw once again.
This is a rigid body which is moving. And yes, am I audible?
Yes, sir.
Yes, sir. सर आवाज येत नाही.
Yes, is it audible now?
Yes, sir.
Yeah, yes.
Yes.
Okay. Okay. Consider the wheel shown in the figure rotating about its axis in clockwise direction. In clockwise direction. Clockwise direction with an acceleration alpha. Let delta m be the mass of an element at a distance r from the axis of rotation. Okay, so this whatever is there, the object is rotating a wheel. Okay, wheel is rigid body, correct? Rigid body, it is rotating. So I want to determine the rotational moment. How much is the rotational moment? So in order to determine the rotational moment, first of all, I am considering a small elemental part. Okay, the small elemental part is having a mass delta m. It is at a distance r from the axis of rotation. This entire mass is rotating with acceleration alpha. Okay, the force which is exerted by the small elemental mass is delta p. I will calculate the rotating moment for the small p, that is elemental part. Then algebraic sum of such a elemental part will be equal to total. Okay, so first I will consider if delta p be resulting force on this element then what is delta p? What is force? mass into acceleration. Okay, so here delta P is the small force on the small elemental body. Okay, what is the mass of the elemental body? Delta M. Okay, delta M. So into acceleration. What is the acceleration? Alpha. Okay, delta P is equal to delta M into alpha. See, don't take alpha, that is the angular acceleration. I will take in terms of linear acceleration. So in linear acceleration, it is equal to mass into acceleration A. So now you can convert a linear acceleration into the angular acceleration. So how to convert a linear acceleration to angular acceleration? R times of alpha. Okay. So here where A is tangential acceleration. So we know that A is equal to R times of alpha. Okay, substituting the equation. So that delta P is equal to delta M into R times alpha, times of alpha. Where now alpha is equal to what? Alpha is equal to angular acceleration. Angular acceleration. Angular acceleration. Okay, next. So rotational moment. So can you tell me what is moment first? Force into distance, perpendicular distance. So I want to find out the rotational moment of a small body. So how much is the force acting on the small element? Force acting on the small element is delta P. What is the distance between the delta P to your axis of rotation? R. So can I write it is rotational moment, that is delta MT rotational moment is equal to delta P into R. Is it correct? Okay. So what is delta P? Delta M into R into alpha into R. So can I write it is delta M into R square times of alpha? Okay. So here delta M T means the rotational moment on the small elemental area you have taken. If I consider the entire area, then what it will delta M become? Capital M. So if I consider total moment, total rotating moment, that is equal to summation of delta M. Is it correct? Into R square into alpha. Okay. So what is constant here? R square and alpha is constant. Okay. I will take alpha outside. Then what is delta M? Delta M is equal to summation of algebraic sum of all the elemental masses is equal to total mass. Algebraic sum of all the elemental mass is equal to total mass. So can I write it is M? Okay, I will write this is M. This is R square. This is alpha. What is M into R square? I times of alpha. I times of alpha. So total rotating moment is equal to I times of alpha. So this is what we wanted. Rotating moment is equal to I times of alpha. Here you can write I is equal to M. I is equal to M times of R square. I is equal to M times of R square. So take a small note. MT is equal to I times of alpha and F is equal to what? M times A. Okay. What is the difference? Here it is angular acceleration, here it is linear acceleration.
Linear
This
acceleration.
multiplied by mass, it will give force. This is multiplied by the mass moment of inertia. It will give rotating moment. Okay. Used in linear motion. Next, force caused linear motion. Force causes force causes linear motion, while while rotational moment while rotational moment, what it causes? Force causes linear motion. This rotational moment causes angular motion. Causes angular motion. Angular motion. Angular motion. Then what is angular momentum? Angular momentum is what?
I omega.
I omega. It is I omega. Okay. Angular moment is equal to I omega. You have written no? The product of mass moment of inertia and angular velocity. Have you written? Angular momentum is equal to. You have written. Okay, angular momentum, the product of linear momentum and perpendicular distance of axis. Okay, you have written. Linear moment, in terms of linear moment, you have written. Is it completed?
Sir,
Yes.
रोटेशनल मोमेंट का इक्वेशन कैसे आया वो समझ नहीं आया.
See, look at the figure first. So the object is rotating with an angle alpha. Correct? What is alpha? Angular acceleration alpha. Okay. What I am trying to tell, please understand. It is a rigid wheel. It is rotating. Okay. This is rotating. This is rotating like this. Okay. With an acceleration alpha. With an acceleration alpha. So I want to determine with, see, if it is a linear, only one body, if it is a body is moving in the linear direction, you tell that F is equal to mass into acceleration. Okay, this is known. So I want to determine it, that total moment, rotating moment I want to find out. Rotating moment is equal to, so you have to consider small part body. Okay, so how much is the force causing on this small particle you have to calculate? That is delta P is the force which is acting on the elemental particle. Okay, so how to calculate delta P? That is your P value. Okay, force is equal to mass into acceleration. Is it understood?
Yes, sir.
Okay, so if this is understood, this is for the elemental area. Okay, I know that acceleration is equal to, in terms of angular acceleration, r times of alpha. Okay, a is equal to r times of alpha. So I'm substituting here. Then delta P is equal to delta m as it is, a is equal to r times of alpha. Okay, this is one equation. This is one equation in terms of delta P. Here you got the delta P is the force required for the elemental area. Okay, I want total force, that is total rotational moment. Okay, first rotational moment you can calculate. Rotational moment is equal to delta P into perpendicular distance. This is r. Okay, delta P value you have calculated. I have substituted and I got the value of only rotational moment on the elemental strip, elemental area. Okay, that is equal to delta m r square alpha. This definition derivation is not asked in the exam. Just for your understanding purpose, I have given. Then you got small elemental moment. Then I want total rotational moment. Total is equal to, you integrate this one. Integrate is nothing but your algebraic sum of all the masses. Is it correct?
Yes, sir.
Yes. So the summation of all the masses into r square into alpha is equal to summation of all the masses means what? Capital M, can I take?
Yes.
Yes, it is into r square into alpha as it is. So you know that r square alpha is equal to I. So I am taking this as I. No, m r square is equal to r. Yes, m r square is equal to I alpha as it is. So moment is equal to, that is rotational moment is equal to I into alpha. Just you have to remember this formula, because while solving the problem, he will be given mass moment of inertia. He will be given angular acceleration. So he is going to ask what is rotational moment. What is the formula of rotational moment?
I
M
I omega.
I alpha, not I omega. I omega is angular momentum. Okay, so this is
Yes, sir.
rotational moment. See, yeah, mt is equal to I omega. I have written that is rotational moment. Then F is equal to m into a. So used in linear equation. This is F is equal to m into a. It is used in linear motion. Then force causes linear motion. whereas rotational moment causes angular motion. Okay. So one more point write down. The product of mass moment of inertia in the note only. The product of mass moment of inertia, mass moment of inertia and angular velocity angular velocity of rotating body is called as angular momentum. Angular momentum. So this angular momentum is equal to angular momentum. You have written in the yesterday class, that is
R
I
omega.
times omega. Okay. Product of mass. See, these definitions are important for your multiple choice questions. He is not going to ask you derivation. He is going to give the definition and what is that one. So angular momentum is it is a product of mass moment of inertia and angular velocity of rotating body. Then what is kinetic energy? Of mv square in terms of linear equation, in terms of angular motion.
1/2 pi omega square.
Omega square into I. Have you written? Have you
Yes.
written? Kinetic energy is equal to half omega square into I.
I.
So there is a derivation for that also, but derivation is not necessary now. Okay, I will not take the derivation. Say derivation. Okay, only 2 lines are there. Okay, take it down, no problem. Easy है क्या? Okay, take it down. Okay, take it down. Kinetic energy of rotating body. Write down. Kinetic energy of rotating body. Consider a rotating body. Write down. Consider a rotating body with angular velocity What is angular velocity? Omega. Let delta m be the mass of an element mass of an element which is at a distance r from the axis of rotation. Diagram is same as you have taken for the previous one. Same diagram. By looking at the diagram only, you can explain this one. Consider a rotating body with angular velocity. Their angular acceleration was there. Correct? Now the body is rotating with angular velocity omega. Let delta m be the mass of an element which is at a distance r from the axis of rotation. Okay. Hence, if v is the linear velocity, linear velocity of element Then what is the relation between the linear velocity and the angular velocity?
R omega.
Yes, very good. R times of omega. See, whatever you have written there, they are recalling, correct? Is over, na? Yes. V is equal to R omega. Then
सर
now,
अल्फा लिखा है.
oh, sorry, correct. R. Alpha, yes. R times of omega. Yes. Then now kinetic energy of elemental mass. Now kinetic energy of element of elemental mass. Okay. See, what is your kinetic energy? Kinetic energy is half mv square, correct?
Yes, sir.
But here we are not considering entire mass. What we are taking only elemental mass. What is the elemental mass? Delta m v square, correct? So what I will write, kinetic energy of the rotating body, kinetic energy of rotating body. See, total kinetic energy. So how to write the total kinetic energy? That is equal to summation of individual kinetic energy. So summation of half of delta m into v square. Is it correct? Okay.
Yes.
Here I will take half is common. Then summation of delta m I will write here into v square. I will write as it is. So you know what is v? What is v here? R omega. Can I substitute R omega?
Yes, sir.
Instead of v square, I will write it is
R omega square.
r square omega square. Okay. So can I take half as it is outside? What is delta m? What is delta m? Total mass into r square into omega square. What is mr square? I. Correct? Half I omega square. That is equal to kinetic energy of rotating body. You have written the same formula? Yes. Okay. So this is the rotation. So just what he has done, he has taken linear motion, first linear velocity. Then he has taken kinetic energy for the elemental strip. Then he has taken kinetic energy for the total rotating body. This derivation is not asked, but you should know what is V is relation between the angular and linear. Then you should know kinetic energy for the linear motion and the total kinetic energy for the rotating body. I omega square. Yes, have you written all of you?
Yes, sir.
Have you written?
Yes.
Yes, sir.
Okay. Let's check now the problem. These problems are important. He is going to ask the problems based on the, see how much you have understood. He is not going to ask the derivation. He is not going to ask the, he may ask the formula or he may ask the problems. If you know the formula, you can solve the problem. Okay, read them. A flywheel weighing 50 kilonewton and having radius of gyration 1 meter loses its speed from 400 rpm to 280 rpm in 2 minutes. In 2 minutes. 2 minutes. Calculate first one. A. The retarding torque acting on it. Then change in its kinetic energy. Change in its kinetic energy during the above period. During the above period. Then change in its angular momentum. Change in its angular momentum during the same period. During the same period. Okay. Okay. So what is given first? Solution. Flywheel weighing. इसका weight दिया flywheel का. So weight is denoted by W. So W is equal to how much? 50 kilonewton. 50 kilonewton. Then again, having a radius of gyration. What is radius of gyration? K value is given. Yes. K is equal to 1 meter. Then loses its speed from 400 rpm to 280 rpm. Initial rotation कितना है? 400 है. 400 to it is coming downward. It is initially rotation. That is angular rotation, angular velocity. Okay. It is omega naught. That is equal to 400. It is 400. RPM is given. How to convert that RPM into the radian per second? See, one rotation is equal to how much? 400. One rotation is equal to how much? 2 pi, correct? So can I multiply this by 2 pi? 2 pi. Then per minute is there. How to convert a minute into 60 seconds? Divided by 60.
Yes,
So
sir.
what is the answer? What is the answer? Calculate. Then final angular velocity, that is final is equal to omega. 41.88. 41.86. 86 or 88. Okay. What is the answer? Unit. Radian per second. Okay. RPM to radian per second convert कर दिया. Then again, he has given final velocity. Omega is equal to how much it is? 280. RPM is given. So 280 multiplied by 2 pi by 60. 2 pi by 60. How much it is? Yes, 29.32. 32 radian per second. Is it understood?
Yes.
Yes.
See, time is given. How much is the time he is given? In order to convert this one, time is 2 minutes. So can you convert this into seconds? 2 into 60. 120 seconds. Yes. What is asked? Retarding torque. So retarding torque is nothing but retarding acceleration. Angular acceleration he is asking. Okay. So if it is a linear, so compare this with the linear motion. If the object is moving, okay, speed is 400 rpm. Okay, initial speed. Abhi final speed कितना है? 280 rpm. Okay, which equation? Initial velocity is given, final velocity is given, time is given. First linear of motion. What is that one? V is equal to u plus 80. Similarly, you can apply the angular motion. Okay, what is that angular equation of motion? Omega is equal to omega naught plus alpha into t. Is it correct?
Yes, sir.
Just what I have taken, I have converted that linear motion of equation into the angular motion of equation. Correct, na? Then what I need to find out? Alpha value. So this alpha value is equal to omega minus omega naught divided by t. Omega is known, that is 29.32 minus 41.86 divided by 120 seconds. So calculate alpha. Is it positive or negative?
28.97.
28.91.
Where you are going wrong? See, omega 29.32 you are typed minus 41.86 you are typed. Bracket डालने का है. If you are not putting bracket, then it is wrong. You have to put the bracket here. This bracket divided by it. नहीं तो वो क्या करते थे? Only 41.86 को divide भी करते.
0.1045.
Is it positive or negative? Yes.
Negative.
0.1047. meter per second square. Okay, so what is this one? Minus means what? Minus means what? It is retarding acceleration. Correct? Huh? If it is a positive, then it is accelerating. If it is negative, means it is retarding. So that is retardation is retardation is 0.1047 meter per second square. Then weight of flywheel is given 50,000 Newton. So what we have to determine? Okay, still I have not determined the first one. Retarding torque I have not determined. What is retarding torque? Yes, what is retarding torque? What is retarding torque? I is equal. Huh? Okay, I times of alpha. Correct? Huh? Do you know the value of this one? Alpha. Alpha. What is the alpha you are determined? Correct? Huh? Then
Yes,
what
sir.
is this one? I you are not determined. We have to determine the I value. So retardation हो गया. Then weight of the what is I formula? M into K square. M into K square. I. So first weight of flywheel. Weight of flywheel is equal to M is equal to 50 kilonewton is given. Can I write it is 50,000 Newton? Okay. How to convert this M into kg? M into kg divided by 9.81 Newton to kg it will come. Okay. So first of all, what is radius of gyration? K is given 1 meter. So I will take I. I is equal to M into K square. M is equal to 50,000 divided by 9.81. Mass आ गया into 1 square. So how much it is? 5096.84. 8084. What is unit? Mass moment of inertia. Kg meter square. Kg meter square. Is it understood, everyone? So this is the point to understand. Okay. So now you can calculate the first one. What is the first one? What is it asking? Retarding torque. So retarding torque is equal to retarding torque. Acting on flywheel. So what is this one? What is the formula? I times alpha. So I is equal to how much? 5096.84 into what is the value of alpha?
minus 0.10.
Minus नहीं डालने का. Minus नहीं डाल because I have already indicated here retarding itself indicates that it is negative. You see 0.1047. Okay, what is the answer? Yes, very good. 533.6 or 7. Okay, 6 or 7. 6. Okay, so it is Newton meter. Okay, write on this first. All of you write down. हेलो सर कॉल किया था आपने मेरे पास है सर हाँ ऐसा क्या ठीक है सर मैं उधर ही रहता सिटी लैब में रहते मैं नहीं अभी लेक्चर में हूँ ओके बाद में Okay, those who have completed first one, calculate the second one. Try karo. What is asked in the second case? Change in kinetic energy during the above period. Just calculate. T1 minus T2. Initial kinetic energy minus final minus initial. Yes. I want only change I want. Final la rakho devo, nahi to initial karo. So which one is larger? Initial or final? Initial is larger. Initial minus final karega. I want change. Change in kinetic. Yes. Who has completed first one? Go for second case. Am I audible? Everyone?
Yes, sir.
Okay. Those who have completed the first one, so go for second one. Yes. What is the second one? Second case. Change in kinetic energy. Change in kinetic energy. Okay. How to find out the change in kinetic energy? Which one is larger? Initially is larger or finally is larger? Initially is larger. So I want change. Initial kinetic energy minus final kinetic energy. Okay. What is kinetic energy formula? Half mv square in terms of linear. It is rotating. I omega. Yes. Half I omega naught square minus half I omega square. Yes. I is common. Both the case 1/2 is common. I is equal to how much? I is equal to 5096. 5096.84. Okay, 84. Okay, take outside. Initial omega, that is 41.86. 41.86. 41.86 minus final, it is 29.32. Yes, calculate. 2567 387. Yes, 2587 2567 2567 387 387.74. Okay, that is Newton meter. Okay. Okay, correct. Is this answer correct? Okay, calculate. Okay, it is just a calculator work. Okay. Okay. So what answer you are going to get? Check karo. Maybe answer may be wrong. Check it.
227471
Yes, correct. 22, correct. Yes, okay, good. Just a minute. Just a minute. Okay, tell me the answer. I will write directly answer. Change in kinetic energy. Change in kinetic energy is equal to. Okay, tell me. 228 427. Okay. Write it. Whatever answer. 228 is correct. Okay, something. Okay, but write it answer. You just calculate and write it answer. Then what is third one? Change in angular momentum. What is angular momentum formula? Yes. Find out. Change in angular momentum. That is equal to I omega of initial minus I omega initial minus I omega of final. So substitute I value is 5096.84 into omega naught. Omega naught is 41.88 or 86 minus 29.32. Yes, calculate. Yes, correct. 6400 or 01? Okay, calculate whatever is the answer. Okay, calculate. It is Newton second angular momentum. Okay, this is the answer for both cases. Hmm? 639.
14.37.
64 is correct. That is 64 no मतलब मेरा आंसर देखो 64
394.37.
014 64014. Okay, what I got is 64048 5096.84 41.88 minus 29.32 640163. Okay, 6401.63. 6401.63. Is it correct answer? 6401. $5096.84 multiplied by 41.86 minus 29.32. 6391 something. Okay, that is something. It is nearer to 64 something kilonewton second. Kilonewton second. Okay, you may get a 63.9 or 64 something. Okay, 64 kilonewton second, nearer to 64. It depends on your this digits, whether you are taken 86 or 88. Yes. Have you written? Okay, this type of problems he is going to ask. Okay, all of you. This type of problems he is going to ask. You have to be very careful. Formulas are important, and by taking the considering formula, you have to be careful. Change in kinetic energy, change in angular momentum, and mass moment of inertia, and retarding torque. Okay. Yes, easy to complete it.
Yes.
Okay. Write on one more side heading. Side heading. Problems on problems. Keep it there pending. I will take one more problem. Okay. So ये step concept बाद में लेंगे. उसके पहले this is important. Take it. That is connected bodies. Two masses. Read on this one. Two masses. 10 kg, 10 kg, and 20 kg, and 20 kg are connected. Problems are connected not on a rigid body motion. It is on a connected bodies motion. Okay, this is also one of the important. Connected with each other by an inextensible thread, and accelerated by the forces by the force of mass 30 kg as shown in figure. Mass of pulley, comma, string, and friction friction at all contact surfaces. At all contact surfaces are negligible. Are negligible. Determine acceleration of the system and tension T1 and T2 in threads Stop. Neglect friction. There are two bodies. First one. That is nearer. 88 liter, 41.88 liter, 41.88. Oh, that is, I have taken 41.86. That may be a difference. Okay, 86 there. That is a difference. This is so this is this is a 10 kg mass. 10 kg. This is 20 kg mass. This is 30 kg mass. So there is a tension T1. This is tension T2. Okay. This is tension T1. This is a rough surface. Here the surface is smooth. He has given in the problem by an inextensible thread accelerated by a force. Mass is given. Mass of the pulley, string, and friction at all the contact surfaces are negligible. Okay. See how to solve this problem. I will give the hints. Okay, it's already time up. I will give the hints you have to solve. Okay. See, first consider the free body. So by looking at the figure, how the body is going to move. Stable. Which one is going to move the downward direction? This 30 kg body is moving downward. Okay. When it moves downward, this body is going to move in this direction. Yes. Consider the FBD of first 30 kg body. Okay. This FBD is moving downward, means how will be inertia force? Upward direction. Then from this equation you will get A and T1 equation. Okay. Then consider the free body diagram of the second 20 kg body. You will get A and T1 equation. Okay. Then you consider 10 kg body. You will get A and T2 equation. Okay. To solve this one, you will get A, T1, T2. What is asking? Is asking determine the acceleration and of the system and tension T1, T2. But neglect friction. There is no there is no friction. Friction is not there. Okay. So just you have to apply the sigma fx formula. All the cases you will get the answer. Okay. I will give the answers also. A. Okay. I will ask these answers in the next class. Okay.
Yes, sir.
Will you solve? Try करते हैं आप लोग? Yes. Okay. Fine. So within 1 minute I will take the attendance. Roll number 1, 2, 3, 4, 5, 6. 6. Roll number 6. 6 is absent. 7, 8, 9. Ruti, why you are not come to the class?
ठीक नहीं है.
Okay, take it. 10, 11. Who is 11? 12, 13, 14, 15. 15 present. 16, 16. 17, 18, 19, 20, 21, 22, 23, 24, 29, 29, 22, 34, present 34, 35, 36, 37, 38, 40, 40. First lecture is there. 41, 42, 43, 44, 52, 53. Who is 53? 53 is absent. 54, 55, 57, 58, 59, 60, 61, 64, 64 is absent. Absent numbers 6, 16, 53, 64. Okay, we'll stop now. We'll continue in the next class. Is it okay? Can I stop?
Yes.